Okay, we'll look at some of the homework problems in section 11.2, which deals with linear measure, where we were talking about the English system of measurement and also the metric system of measurement and some other things that dealt with converting from one unit to another. Problem number one is this. You want to complete the following. 110 inches is equal to how many feet? Okay, we have to know that 12 inches is equal to 1 foot. 12 inches is equal to a foot. Okay, so we have 110 inches, and we're converting that to feet. So here, what we're converting from goes on the bottom. What we're converting to goes on the top, which is your feet. So inches go on the bottom, feet goes on the top, and the respective numbers would go with their respective units. 12 inches, the 12 goes where the inches is equal to 1 foot. The 1 goes where the foot is. Okay, so here we're using a unit analysis, which means we can divide out the inches and do 110 divided by 12. Now they want this as a simplified fraction, so 110 divided by 12, and you can convert this as a fraction in simplest form. It will be 110 over 12, but in simplest form it's going to end up being 55 over 6 when you divide the numerator and the denominator by 2. So as a simplified fraction, it'll end up being 55 over 6 feet for 110 inches. All right, number 2. This one you're going to complete the parts A through E in the table. Okay, in this case here, the length of a piece of paper, and your total is 39 centimeters. You want to convert that to meters and also to millimeters. There was the conversion table that I gave you in one of the videos, where you have the kilometers, then hectometers, then decameters, then the base unit, which is meters, and then decimeters, centimeters, and then finally millimeters. Okay, we know 39 centimeters. We want to convert that to meters. In this case here, from centimeters to meters, we have to go 2 places to the left. So in point 39, in 39, you want to move the decimal point 2 places to the left. So the decimal point would be in front of the 3. So 39 centimeters converted to meters will be 0.39. Okay. Might not be able to see it in that box, but it's 0.39 centimeters. Just 0.39 meters. I'll write that up here. Now we want to convert that to millimeters. Centimeters to millimeters is 1 place to the right. So we need to move this decimal point in 39 1 place to the right. So that means we need to add a 0 here to move the decimal point 1 place to the right. So it'll end up being 390. Okay. Part B is the height of a woman, which is 1.68 meters. We want to convert that to centimeters and then to meters. Well, we're going from meters to centimeters. Meters to centimeters, that's 1, 2 places to the right. So in 1.68, the decimal point is behind the 1, so you're going to move that decimal point 1, 2 places to the right. So it'll be 168 centimeters. Okay, now from meters to millimeters, that's 1, 2, 3 places to the right. So we need to move this decimal point 1, 2, 3 places. We need to add a 0 here, so that'll be 1680. 1,680 millimeters. Next is the width of a film strip, which is 38 millimeters. We want to convert that to meters and to centimeters. Let's convert this to centimeters first. 38 millimeters to centimeters, that's 1 place to the left. So the decimal point is behind the 8. We need to move it 1 place to the left. So it'll be between the 3 and the 8. So this will be 3.8 centimeters. Now convert 38 millimeters to meters. This will be 1, 2, 3 places to the left. So we need to move the decimal point in 38, 1, 2, 3 places to the left. So a 0 will be in front. So you need 0.038 meters for the width of the film strip. Okay, part D is done the same way. You have a length of a cigarette, which is 101 millimeters. We're converting that from millimeters, let's say, to centimeters. Well, from millimeters to centimeters, that's only one place to the left. So in 101, we need to move that decimal point one place to the left. So it'll be behind the 0. So it'll be 10.1 centimeters. And then from millimeters to meters, again, that's 3 places to the left. So we need to move the decimal point 1, 2, 3 places to the left. So it'll be in front of the 1. So it'll be 0.101. And then the length of 6 meter sticks laid end to end, that's 6 meters. We want to convert that to centimeters. Well, from meters to centimeters, that's 1, 2 places to the right. So the decimal point's behind the 6, so you need to move the decimal point 2 places to the right and add 2 zeros. So that's going to be 600 centimeters. And then from 6 meters to millimeters, meters to millimeters, that's 1, 2, 3 places to the right. So we need to move that decimal point 3 places to the right, which means we need to put 3 zeros behind the 6. So it'll be 6,000 millimeters. Okay, so that's how you would complete that table of conversion from one metric unit to another metric unit. And the metric system is the easiest one because it's based on the base 10 system, which is our numeration system. Problem number 3. Complete each of the following conversions. 40 millimeters to centimeters. And again, I'll write that particular table for kilometers, then hectometers, decameters, meters, then decimeters, centimeters, and millimeters. That way this can help you convert from one unit to another. Alright, in this case here we're converting 40 millimeters to centimeters. Well, millimeters to centimeters, that's one place to the left, as you can see. So in the 40, we need to move this decimal point, which is on the end, one place to the left. So it'll be behind the 4. So 40 millimeters would be just 4 centimeters. And then next is 287 meters to kilometers. So from meters to kilometers, that's 1, 2, 3 places to the left. So in 287, we take the decimal point, move it over 1, 2, 3 places. So the decimal point will be in front of the 2. So it'll be 0.287 kilometers. And then part C, 4 kilometers is equal to how many meters? From kilometers to meters, that's 1, 2, 3 places to the right. So in the 4, where the decimal point is behind the last digit, we move that decimal point 1, 2, 3 places. We need to add 3 zeros behind the 4. So it would be 4,000 meters for 4 kilometers. 4,000 meters. And then 20 millimeters converted to meters. Millimeters to meters, that's 1, 2, 3 places to the left. So in 20, the decimal point's behind the 0. We need to move the decimal point 3 places to the left. So a 0 needs to be in front of the 2. So you have 0.0 0.02 meters. And you can drop off the 0 behind the 2. So it'll be 0.02 meters for 20 millimeters. Okay. All right, problem number 4. Can the following be lengths of the sides of a triangle? You have 11 centimeters, 13 centimeters, 23 centimeters. Okay, in a triangle inequality theorem, it says the sum of the first and the second must be bigger than the third. Then the sum of the second and the third must be bigger than the first, and then the first and the third must be big. The sum of the first and the third must be bigger than the second. So here, if I add the first and the second, that's 11 plus 13, that's 24, which is bigger than 23. We're okay with that. Now add the second and the third lengths together. 13 plus 23, that's 36. That's bigger than 23. And then add the first and the third, 11 plus 23, that's equal to 34. That's bigger than the second, which is 13. And I said this should be bigger than the first, which is 11. In this case, that's true. So all instances, the sum of the two sides is bigger than the other side, which is what we want. So in this case here, our answer there will be yes. Problem number 5. Find the radius of the circle with the given circumference. Here the circumference is 8 pi centimeters. The formula for the circumference of a circle, and we're finding the radius is going to be 2 pi r. And the circumference is 8 pi, so we replace this c with 8 pi. That's equal to 2 pi times r. Now we want to find out what r is. We're multiplying by 2 pi, so we need to divide both sides by 2 pi. So in this case here, the 2 pi's divide out, you're left with the radius. On the left side, the pi's divide out, you're left with 8 divided by 2, which will be 4 centimeters. So the radius of that circle, where the circumference is 8 pi centimeters, would be 4 centimeters. Okay, so that's how you'll solve a problem where you're given a circumference and you want to find the radius of that circle. Okay, problem number 6. Another circle problem. If a circle has the dimensions given, determine its circumference. In part A, you have a 13-foot diameter, and in this case, you want to find out what the circumference is. The diameter is given, so all you'll need is this formula. C is equal to pi times the diameter. Okay, so in this case, the diameter is 13 feet. So here, this will be pi times 13. And the directions tell us to type in the exact answer using pi as needed. So our circumference, we'll just leave that as simply 13 pi. And it'll be 13 pi feet, because the diameter was given to us in feet. And you'll just type in the number 13 pi. Part B, the circumference with a 20 over pi foot radius. The radius is given, so you have to use this formula. C is equal to 2 pi r. So to find the circumference here, bring down the 2 pi. The radius is 20 over pi, so we got 20 over pi times 2 pi. Now the pi's will divide out, and all you have to do here is multiply 2 times 20. You're going to get 40, and that'll be 40 feet. So the circumference of that circle with a 20 over pi foot radius is 40 feet. Okay. Problem number 7. Again, another unit analysis problem. 330 inches is equal to how many feet? Now, if you recall, on one of the problems I did, 12 inches is equal to a foot, and you're converting 330 inches to feet. You're converting from inches, so inches go on the bottom, to feet, so feet goes on the top. And you'll put those numbers next to their units. 1 foot would go where the 1 would go where the foot is. 12 would go where the inches is, because 12 inches equal a foot. The inches divide out. So now you have 330 divided by 12. And they want this as a simplified fraction in simplest form, so it'll be 55 over 2. And it'll be 55 over 2 feet. And problem number 8. Can the following be lengths of the sides of a triangle? You have 17 centimeters, 12 centimeters, 19 centimeters. Again, the sum of the first and the second must be bigger than the third. So in this case, it's 17 plus 12 is 29. It is bigger than the third, which is 19. Then the second and the third, the sum of those two must be bigger than the first. So 12 plus 19 equals 31. That's bigger than the first, which is 17. Then the first and the third, 17 plus 19 equals 36, which is bigger than the second, which is 12. So here, all those conditions are satisfied. So yes, those lengths can be the sides of a triangle. Okay, so that should help you with the homework in section 11.2.